Good morning, guys. So, welcome to NEET World for both online and offline students. Okay, so in this class, we are going to see particularly about the EAPCET program, right? So, this is day 5 of the EAPCET program for physics. So, till now we were in the topic of like units and dimensions and measurements and errors, and today we are going to the next topic, that is kinematics. That is, in that first part we are going to see is motion in a straight line. Okay, so let's wait for 1 or 2 minutes. People are joining. Let's wait for them. So people are joining. Let's wait for 1 more minute, and I hope you that so, and I hope that everyone are doing well in the first chapters, right? We were doing the problems in the last class, and I have given some questions to do also, right? You have completed. Yeah, very good. That's good to hear. You have completed. Fine. So the thing is, whatever we are doing, no, like take a note of that everything, like each and every steps. Okay. So if we are seeing some formulas, note down the formulas particularly, like if we see in kinematics, the kinematic equations will be there. V is equals to u plus at, u square, so v square minus u square will be equals to 2as, right? So these kind of formulas you should be noted down, and you should remember those formulas. And in last class I have given some dimensional formula for quantities, right? Almost around 50 to 60 dimensional formulas. No, so you keep remember those formulas, like keep on revising those formulas. Like I'm not asking you to complete everything in a day, single day. No, take at least five in a day. So in the sense, like in a week you can complete 30 to 35, na? Right? So 2 weeks, if you keeps on revising those things, na, the dimensional formulas, it will be in your mind. Okay, so that one you should do it. Then the solving method is there, no, like a calculation, whatever it is. Okay, it should be fast enough you to complete that problem. Like don't take too much time for calculation. Okay, so if you are not getting the calculation in that time, okay, but for simple calculations don't take too much time. Like take the problem, complete it as soon as possible, so that you can go for the next problem. Okay, so you are dealing with the 40 problems, right? So 40 problems in physics, so you should complete it. See, it's not easy enough, right? People who are going for the first time in EAPCET, or who are appearing for the EAPCET, the pattern for the pattern, right? So 160 questions almost, you should complete it everything, right? Okay. So today let's start with kinematics. How the things are moving without without asking why they are moving, like without asking how why they are moving or how they have started. Okay, so why they are moving. Okay, so this is the thing. So in the first part we are going to deal with motion in a straight line. Motion in a straight line. So here we can understand the things like one is rest and one is a motion. Okay, so first of all, the meaning of motion is nothing but it's a moving, no, moving. So in a straight line, in the sense, like I can say there are three axes. What are they? X, Y and Z. So either the object is going in x direction, y direction or z direction. Okay, in a straight line, no, in a straight line, right? So moving in a straight line. Okay, fine. But how we are saying the objects is at motion or is at rest? That's the question over here. How we are saying the objects is at motion or is at rest? So for that we are taking a reference frame. So reference frame in the sense, like for example, let me consider point A and point B. Point A and point B. So if point B changes its position, this is initial position of point B initial, okay, and this is final position of point B. Now what we can say, for A, B is in motion, no, B is in motion. For B also, like it's moving, right, it's moving. So for A, B is in motion because it changes its position, because B changes its position, right, changes its position. Now if I consider C here, for A, C will be in rest because C doesn't change its position, only B changes. Initially B was here, B came here. Initially C was here only, final also C was here only. So with respect to A, no, like B is in motion, C is in rest. Okay, then what about C? C with A will be in rest, B will be in motion, right now? Yes. So with respect to some objects, we can say the objects are in motion, objects are in rest. Okay, so motion in the sense like changes its position, whereas rest, no change in position, right, no change in position, right. Okay, so here we are going to deal with the two topics, one more, like two important topics, that is inertial frame and non-inertial frame. Inertial frame and non-inertial frame. So what is inertial and non-inertial frame? So inertial frame, no, like the frame is not in acceleration. The frame is not in acceleration, we can say. Frame is not in acceleration, whereas non-inertial frame will be in acceleration. Frame will be in acceleration. Okay, so these are the two things whenever we are dealing with the motions. Okay, we need to remember whether it's an inertial frame or non-inertial frame. Okay, you can take a note of this. We'll go for the next topic. Okay, done. So we have talked about the straight line. Okay, so straight line, we can say it as one dimensional. Okay, 1D we can say, one dimension, whereas plane, it is 2 dimension, and space, it is 3 dimension. Okay, so straight line 1 dimension we can say, and the plane 2 dimension, space is 3 dimension. So in this particular topic we are going to deal with the straight lines only. Okay, that is either x or y or z. Okay, whereas this one xy or yz or zx, and in this xyz. Okay, no? Yes. Now let us see the topic displacement. So let me take this as symbol, yes. Okay, displacement. So here displaced or displacement, the meaning of this, no, like it changes its position. It changes its position, yes. Changes or changing in position, changes its position. So for example, delta S let me take. Okay, for example, initially object was at point A and it has moved somewhere to point B, right. Initial position of the object was at point A, at final point B. So displacement is nothing but B minus A, that's it, changes its position, right. Or else we can say this is x initial, x final, so I can say x final minus x initial. Okay, so SI unit is meter, SI unit is meter, okay. Whereas dimensional formula is L, or else we can say M0, L1, T0, right. So this is about a displacement. So when we go for the next topic, that is velocity. So velocity is nothing but its displacement by time, we will say. It's a ratio of displacement and time, right. Change in position with respect to time is known as velocity, we will say, right. Or else we can say change in position with respect to time. So V will be equals to delta S by T, okay. So in this velocity, no, like, okay, first we will see what is the SI unit. SI unit is meter per second, dimensional formula is M0 L1 T power minus 1. This is the dimensional formula, no, okay. So in this, no, like we are going to deal with instantaneous velocity, What is the meaning of instantaneous? Instantaneous is nothing but at that particular moment, what is my velocity? Suppose a person is driving a vehicle, okay, from Hyderabad to Vizag, okay. Now what the thing is, like when he is traveling now, in between any place, I am asking what is the velocity. So he is saying something like 80 meter per second, or sorry, 80 kilometer per second, like that, okay. So that is my instantaneous, So what is average velocity? So average velocity is nothing but so total displacement by total time taken, total displacement by total time. So for instantaneous we will use V will be equals to ds by dt, okay. Take a note of this. Okay. Now, without go, I mean, no, by far, so for going for next topic now, before that we'll start with, we'll see one more thing, that is distance. Okay, distance. So, what is the distance means? So, distance is nothing but total path travelled. So, then what is displacement? It is shortest path travelled, or the actual path we will say. So, actual path. So, whereas displacement it is shortest path, right now. So, let me write here the difference. So, displacement. So, this is a scalar quantity, we can say scalar, okay, and whereas this one is a vector. Why we are saying this is a scalar and a vector? Because this one is dealing only with the magnitude, not the direction, whereas displacement deals with both magnitude as well as the direction, right? So, for example, let me take point A, point B, and this is point C. So, I am travelling like this, okay. So, point A to B is 10 kilometer, point B to C is 8 kilometer, okay. So, what is the distance from A to C? A to C. So, 10 kilometer travel, like A to B 10 plus B to C 8, 18 kilometer, right now. Whereas, for this particular thing, when we are seeing in displacement, right, how much? A to C? Only 2. I can travel from here to here directly, not I am going there and coming here. It's actual path, but the shortest path is 2, right? So, 2 kilometer. So, the thing is, we should consider either it is going in north, south, east, west, like the direction is important thing. The direction is important thing. So, going like this plus coming again like this minus. So, 10 minus 8 is 2, 2 kilometer only we are travelling, that is it. Okay, 2 kilometer we are travelling, right? And what about the SI unit of this? Same SI unit, that is meter, right? The same SI unit, the meter only. So, I will give one more example over here. So, let me take a graph here like this. So, for example, from this is let me take 0, 0 and this point is 5, 0. So, I have travelled like this. This is the point like 2 and this is 4, for example, I will take, okay, 2 and 4. This is 2 meter, or you leave this one, 2 meter from A0 to, I mean O to A to B, B to C, 2 meter, 3 meter, 4 meter, for example, okay. So, what is the distance travelled from O to C and what is the displacement from O to C, right? O to C distance and O to C displacement I need to find. So, when I look over here now, O to A to B, B to C, this is the actual path, 2 plus 3, 5, 5 plus 4, 9, okay. Whereas, this is my shortest path, I can go directly like this, right now. So, what is the shortest path? 5, that is it, 5 and this is 9. So, this is my distance and this is my displacement, got it? Okay. Okay, fine. Now we'll see what is speed now. Speed is nothing but distance by time. So SI unit is meter per second, dimensional formula is m0 L1 t power minus 1. Okay, then average speed is nothing but total distance by total time. Okay, total distance by total time. Yes, the thing is like velocity, like total displacement I have given, that is change in displacement, we can say change in displacement by change in time, that is velocity. Okay, will denoted by some vector. Okay, so whereas v will be given as s by t, this is velocity and this is speed, will say, because I have denoted with arrow mark the vector. Okay, so we can yes, we can use that vector symbol and we can say that it's a velocity or it's a speed. Okay. Okay. Fine. Now is the question here, from point A, object has been started with velocity v1 and after some time it returned back to the same point with a velocity v2. I need to find average velocity. Second question is average speed, right? Average velocity and average speed. I have given the idea about velocity, average velocity and average speed. So when a point point is given and it has been travelled somewhere and came to the same point, displacement will be 0, because change in displacement is nothing but SF minus SI, like final position minus initial position. So A minus A will be equals to 0. So when I talk about the average velocity, change in displacement by change in time is nothing but 0 by time, be 0. So I got average velocity. What about average speed? Yes, I need to find it, right? So distance is same distance. Let me take this distance as x. Okay, x. So v1 will be equals to x by t1, v2 will be equals to x by t2, right? Okay, I can rewrite this one as t1 will be equals to, in terms of t I can write, na? Yes. So v1 I know, x I know, like the distance, and I know like speed I know, I don't know about the time. So t1 will be equals to x by v1, t2 will be equals to x by v2. So v average will be equals to v1 plus v2 by, sorry, x1 plus x2, right now, x1 plus x2 by t1 plus t2, total displacement by total time taken, right now. So what is x1, x2? x1 will be equals to x2 will be equals to x, the total, like the distance it has been travelled, I can say, no. So I'll write here x plus x by t1, x by v1 plus t2, x by v2, right? So I'll take x commonly outside from here, x into 2 divide by x into 1 by v1 plus 1 by v2, x and x will get cancelled off. So I can say that 2 by v2 plus v1 by v1 v2, which is nothing but 2 v1 v2 by v1 plus v2 is the answer for the average distance or sorry, average speed the object has been travelled from point A and it has been written with some without with some other velocity or some other speed with point same point B or same point A. Okay. So, this is my formula. Now, can we do the next question? Okay. So, let me take a object has been travelled some x distance, that is point A to B. So, first 1/3 speed was V1, second 1/3 speed was V2, the last 1/3 speed was V3. What is the average speed? What is the average speed? This is my question. Okay. Now, if I see here, it has been divided into 3 equal parts. Now, 3 equal parts in the sense x by 3 V1 T1, x by 3 V2 T2, x by 3 V3 T3. So, it has been divided like this. So, can I say from this T1 will be equals to x by 3 by V1, T2 will be equals to x by 3 by V2, T3 will be equals to x by 3 by V3, right? No? So, average speed na x1 plus x2 plus x3 by T1 plus T2 plus T3, where x1 will be equals to x2 will be equals to x3 will be equals to x by 3. So, let me write here x by 3 plus x by 3 plus x by 3 divide by T1 is x by 3 by V1 plus x by 3 by V2 plus x by 3 by V3, right? So, let me take x by 3 commonly outside, x by 3 1 plus 1 plus 1 divide by x by 3 1 by V1 plus 1 by V2 plus 1 by V3. So, x by 3 got cancelled out. So, can I write here 3 by, first I will cross multiply these two things, V2 plus V1 by V1 V2 plus 1 by V3. Yes, correct. Then I will cross multiply this one now. So, 3 by V2 V3 plus V3 V1 plus V1 V2 divide by V1 V2 V3. So, the final answer will be looking like this, 3 V1 V2 V3 by V1 V2 plus V2 V3 plus V3 V1. This is my average speed. This is my average speed. We will do one more question in this type and then we will go for the next one. Okay. Yes, we'll do one more type of question like this, okay, and we'll go for the next type of questions, okay. You can take a note of this. Yes. So the next question is, from point A to point B, okay, point A to point B, distance is x. So first, 1/3 of a distance, 1/3 is nothing but V1, that is x by 3 or 1/3 we will say, okay, x by 3, okay, x by 3. Whereas the 2/3, that is 2x by 3, that is V2. Now I need to get what is the average speed, okay, average speed. So let me write here, x by 3 V1, x by 3 V1, T1, that is one more is x by 3, so 2x by 3 V2 T2, right? No, right. Now can I write T1 as x by 3 by V1, T2 as 2x by 3 V2. So this is x1 plus x2 by T1 plus T2, where x1 will be equals to x by 3, x2 will be equals to 2x by 3, right? So it's not a similar type, okay, like x I can take commonly from this, but in the previous case x by 3 I have taken commonly outside, okay. So here we need to do carefully, x by 3 plus 2x by 3 1, okay, divide by what is T1, x by 3 by V1 plus 2x by 3 by V2, okay. But here one thing we can make sure that 3 I can take 3 also commonly outside, so it's very easy, na. X by 3 I will take commonly outside. What is the answer? 1 plus 2, fine. Divide by x by 3 I will take commonly outside, 1 plus 2, 1 by V1, 2 by V2, okay, fine. Now that's it. So x by 3 got cancelled out. So here 3 divide by, cross multiply it, V2 plus 2V1 by V1 V2. So final answer will be 3V1 V2 by 2V1 plus V2. This is my answer. Got it? So can we go for the next question? Okay. So next question is given as like 5t square minus 4t plus 20. They have given the equation like x is equals to, okay, that is x is equals to 5t square minus 4t plus 20. The first question, take down, find average velocity between, find average velocity, yes, find average velocity between 1 second and 3 second, 1 second and 3 second. Instantaneous in the sense nothing but like I can differentiate the given equation and I can substitute the time there, that's it. I will give that also. So, second question, like find instantaneous velocity at t is equals to 3 seconds. Okay. These are the two types of question they might ask. So, the first question how we can solve is average velocity, no, at 1 second what will be the displacement, at 3 second what will be the displacement, right? Right now let me write here average velocity is nothing but change in displacement by change in time, right? Change in displacement by change in time. So, I can say like change in displacement SF minus SI divided by change in time, right? Right na? Okay. So, at t is equals to 1, t is equals to 1, S will be, S initial will be equals to, what is the thing? 5 into 1 minus 4 into 1 plus 20, which is nothing but 5 minus 4 plus 20, 25, 21 initial, right? Final SF will be equals to 5 into, okay, at t is equals to 3, S final will be equals to, S final will be equals to 5 into, okay, this is square now, 5 into 3 the whole 3 square minus 4 into 3 plus 20. So, 5 into 3 square is 9 minus 12 plus 20, 45 plus 20 minus 12. So, 45 no 57 minus 12 is nothing but how much it will come? 57 only, no? Oh, sorry, this is not 57, 65 will come, na? 65 minus 12, okay, 53, right na, 53. Now, I can substitute the values directly now, right, I can substitute the values directly. What is the values? SF 53 minus 21 divided by change in time 3 minus 1. So, 53 minus 21, 21 30 and 32, 32 by 2 which is nothing but 16 meter per second. This is my average velocity, simple na. This is how we will do average velocity, like I need to find what is the displacement at t1, what is the displacement at t2. So, SF minus or XF minus XI by t2 or TF minus TI, okay, I can find like this. And what about the instantaneous, guys? So, instantaneous, no, like x is equals to 5t square minus 4t plus 20 is the equation they have given. If I differentiate the equation, no, dx by dt will be equals to v, yes, so displacement by time, no. So, differentiate this equation, 10t minus 4 constant, leave about that one, will be equals to v. So, at t is equals to 3, no, 10 into 3 minus 4 will be equals to v, 30 minus 4 is 26 meter per second is the velocity. So, at 3 seconds 26 meter per second is the velocity, okay. Got it na? Yes. I am giving one more question over here. Suppose I am considering a circle like this. Let me take a shape, okay. So, I am considering a circle. For the circle, no, this is the initial point. A is the initial point. It has been travelled, the object has been travelled and came to the same initial point only, okay, same initial point, and the circle is having a radius r. So, what is the displacement and what is the distance of the object? Displacement, initial position A, final position also A. So answer will be 0. What about distance? So circumference of the circle 2 pi r. 2 pi r. These are my displacement and distance of the circle when it starts from the point A and come to same point A. Only one revolution has been taken place. If it go for 2 revolution, no, for this it into 2 and for this 0 only, right? First revolution, 1 revolution means 1 circle it has been completed, displacement 0, distance will be 2 pi r. It going again and coming back, displacement will be again 0 but distance will be 4 pi r. Okay, distance keeps on increasing but whereas displacement will be 0, it will be constant because it doesn't change its position. No. Now if I talk about the point B now, what is the displacement and distance? Displacement will be shortest path. Object can travel like this also and it can travel like this also, no, right? Displacement will be 2r whereas distance will be 2 pi r, no, divide by 2 like half of the circle na, so pi r. Pi r is the, yes, distance and displacement, right? So with this I'll stop the class of this session and we'll go for the next topic in the upcoming classes, right? I hope you got whatever we have learned today, right? Now I hope you got everything like whatever we have learned. Okay, we have learned the reference frame, non-inertial, inertial frame, and then velocity, speed, displacement, distance, everything, right? And we have solved some questions also. So in upcoming class we will see or we will discuss about the acceleration, one dimensional motion, that is kinematic equations we will see, and some questions we will solve in the kinematics equation. Okay, so thank you guys. With this I'll end the session. We'll meet in the next class.